Hi there, this is World Quality Month, and I am sharing with you videos around the basics of quality as an overview so that the voice of quality can reach more people and we can de jargonize quality a little bit. Over the years, quality has become a little complicated for most people to understand and, of course, then to follow. My mission is to make it a little simpler, make it a little bit more user friendly, so that all of us can understand the basic principles and then adapt it to where we want it. But who am I to do all this? I am a senior transformation, innovation, quality, and simplification professional who works across large global organizations to make processes simpler and quality better. In short, operational excellence. I am also a fellow of the American Society of Quality for several years. And earlier in my career, I was 40 under 40 for global quality professionals. So I have some credentials to speak about this topic. In my two previous videos in this series, I have spoken about some introduction and fundamentals of quality management as a subject and then some frameworks and tools. In this video, we will dive a little deeper into how does quality actually work, and I will take a background of the manufacturing sector, but extrapolate it to services with some examples where feasible. The endeavor is not to turn this into a lecture for students of quality, maybe in engineering or MBA classes, but more to keep it for the larger masses so that people can understand and hopefully then develop some interest and implement it. So, with that intention, we will get deeper into this. So, how does quality work? I'll cover five brief topics. One, quality control versus quality assurance. What comes when and which is better. Two, the role of data in quality. And this is extremely important because eventually a lot of quality management methods are dependent on data. Three, process mapping. How can we flowchart and map our processes to understand them better and then, of course, to improve them? Four, very important, root cause analysis. Eventually, all quality improvement comes down to root cause analysis. If we cannot identify the root cause, we might put a remedy in place, but it will not be long lasting. And finally, the fifth one, statistical process control. So, with that, let's attack the first topic, quality control versus quality assurance. Some basics. Quality control or QC ensures that product and services meet specifications after production. So, if you are making a product or delivering a service, for example, you are an insurance company and you have to fulfill claims that are filed. Now, this is a process, a service process. And your assurance to the customer is that we will fulfill our claims within 3 weeks, let us say. Your method of quality control should focus on understanding how many times or in what percentage of cases you are able to meet that 3 weeks. For this to happen, several sub processes will have to happen in 2 days, 3 days, 1 day, half an hour, and so on. So, quality control will go down to that level to make sure all those processes are happening within the time duration that is expected so that the overall time duration can be met. So, quality control is not just about meeting the overall specification, it is also about meeting the specifications at the sub process level or the activity level. So, what is quality assurance? Quality assurance, as the name suggests, is about assuring the customer that we will be able to do this. Now, take the previous example. You are an insurance company which has assured that you will fulfill all claims within 3 weeks, or let's simplify it, within a week. Now, we understood that how will you control the process, but the assurance part is that you will prevent these defects from happening. So, what all will you do before the process happens? For example, training, education, making sure systems are in place, your job aids are in place, and you are able to create systems and processes which will make sure that the defects do not occur. And if the defects do occur, they are caught within time and corrected in time, and so on. All this is quality assurance. I don't have to explain to you that quality assurance is probably the safer and better thing to do. Of course, you will need some control because things do go wrong, but you cannot depend on control to catch everything. You will need elements of quality assurance to do this. So, quality control or QC is about detecting errors, and quality assurance or QA is about designing error proof processes or limiting errors. Both are essential for maintaining high standards in both manufacturing as well as service industries. One can say that QA is a little proactive while QC is reactive, but that would be slightly wrong to say because QC does what it is asked to do. There is no need to judge its intention. QC is designed to control and it does a good job of it. What is also required is a little bit of QA before the QC process. So that was quality control and quality assurance. The next topic is role of data in quality. I will tell you a little anecdote. The first quality improvement project that I ever did was in a textile manufacturing firm in Nagpur, India, where I was an employee. It was probably the first project I did. And we asked for data around productivity and production of a shift in a textile unit. And we kept asking for the data. When I say we, there were 2, 3 people in that project. And eventually we got the data. And I can assure you that that project is still on 30 years since, because what we did not know was the classification of data. What is the data that we were asking for? So if you don't ask for specific data, you will get general data and you can never complete a project with general data. So back to the topic, the role of data in quality. Data helps in tracking performance and identifying issues. Again, back to the earlier process of the insurance company of a claim filing process. And if you have data across the several sub processes in the claims process or even in the issuance process, you can then identify where is the, let's say 90% of the claims are delayed beyond 1 week and go into the second week. You can then look at the data at the sub process level and say, oh, okay, the delay is mostly happening in analysis of the documents that the customer has submitted. So you can go about improving that part and hopefully then the process will come down within a week. Statistical tools like statistical process control or SPC are used to monitor quality. This will give you the data at the sub process level or activity level, and as I explained earlier, that will help you solve the problem. Data driven decisions reduce guesswork in problem solving. You will find a lot of people in meetings saying that, oh, leave it to me, I know what this process is. I can assure you they know nothing because they are talking in a quality environment without data. You should not be looking at such solutions at all because these solutions might be solving the problem today, but the problem will come back tomorrow. Now, how much data should you collect? How often should you collect? It really depends on the process. If your process is a daily process, then which means the outcome is daily, then of course you need a hourly data collection. If your process is such that it completes in a, then maybe a daily data collection is fine. Simple metrics like defect rate, cycle time, total time taken, and of course customer feedback, all these are important. So these are the types of data that you can use in quality. So we've understood quality control versus quality assurance. We have understood the role of data. Now let us look into a very, very important topic in quality, process mapping. Process mapping is an advanced method of the flowchart tool that Dr. James Duran taught in the 7 tools for quality improvement. And the tool itself comes from computer science, where a flowchart or a program flowchart was drawn to develop the logic for the software program that you were writing. So again, going back to the example that we took, the claims process of an insurance organization. If you have to map the process, you will have to map customer files the claim, how's the claim filed. You can go into detail of how many types of avenues you have provided for the customer to file complaint. The customer has filled a form. The form will be an input to the process where it will be then recorded. It will probably be recorded in an electronic form. Then somebody will have to check it at an initial level to admit it or to reject it. There will be some investigation. All these are process mapping steps. So process mapping visualizes each step in a workflow. How is the work flowing? Because then only you can find out where is it getting stuck. It is like a pipe where some water or a liquid is flowing, and if you assess it properly, you will be able to figure out where is the water or that liquid. The process mapping will help you identify bottlenecks, redundancies, and opportunities for improvement. Process mapping will help you identify complex processes and make them easier to understand and then optimize. And it, of course, helps in standardizing best practices. Once you have a good process and you have documented it well through a map, you can actually train and teach people. So that is a huge boost because then everybody will do the same process. And I keep saying that a good way to achieve high quality is industrialization and standardization. So if you standardize the process to the extent that everybody does it the same way, you are more likely to get the same output through the process. Next up, root cause analysis. There are many ways to look at it. Some people use the term 5 whys and so on, but essentially it means that you have a multitude of causes for the effect that you are seeing. So in the example we are taking, if the claims process is delayed, let us say by a week, then there are multiple causes for it. We don't know the root cause. So you will have to do some analysis to find out the root cause. There could be multiple causes. There could be system errors. There could be people errors. Customer could have written wrong information. We could be having the wrong database and so on. But there will be some dominant root causes from this, or a root cause. Asking 5 whys, as in this case, if the claims are delayed, asking why is the claim delayed? Because the system updates are not there. Why is the system update not there? Because the batch process was not run, the data was not available, and so on. If you keep asking this like 4 to 5 times, you are likely to get to a stage where a very, very solid root cause will be available. Another example, that the claims were delayed because the claims processing team was not available. Why was it not available? Because their shift starts at 9, whereas the claim starts at 7. You can keep asking this. Eventually, the answer could be, oh, can we not ask the claims team to come at 7, or can we not ask one team to come at 7 and do some due diligence so that the work is ready at 9 for the other team to take up? Similar to 5 whys, there is another tool called Ishikawa diagram, or also called fishbone diagram, because of this. It is also a very structured way. Otherwise, what will you do? You will come into a room and think and talk about a problem and think that you have achieved root cause. But you might have missed multiple other root causes. Or in the excitement on the room, whatever is the loudest opinion or whatever is the most popular opinion might prevail. In that case, again, you have missed out on the possible real root cause. So using a structured method is always helpful, because then the quieter voices are also heard and logic prevails, and you will also be able to look at data and go one by one on all the root cause. Of course, the bottom line to all root cause analysis is focus on fixing causes and not just symptoms. So you are not looking at a quick fix to solve just the symptom, you are looking at root causes. Next up, final topic in this video, statistical process control. So as the name suggests, this is a statistical method to help do some process control. Now, one of the misconceptions in this whole thing is that the process itself is being controlled. Actually, the inputs are to be controlled for the process to be controlled. The method was originally developed by Walter Shewhart, and who in a way was the guru for Dr. James Juran and Dr. Deming both. And in the beginning, this was purely a statistical method where the control on the process was to be established. Later on, Dr. Deming built and taught this topic further. So SPC will help distinguish between normal variation and actual defects, right? In that sense that every process will have some normal variation that is expected. In the example that we are taking of full claims process, there will be some natural variation, right? So if you are going from your home to your office, let us say it takes 23 minutes every day on an average for a month. Some days it will take 20, some days it will take 25. So there is certain natural variation. This natural variation is between plus minus 3 sigma in a process sense. I will not go deeper into this because this video is not meant for that process, but you can understand that there is some natural process. But on some days there is some unnatural variation, right? Let us say there is a huge traffic jam, there is an accident on the road, or other things happen, right? That you can't control. That is also called sporadic variation, right? So, but there is chronic variation. So, SPC, or statistical process control, will help you reduce the chronic one. It does not have any control on the external forces or the sporadic variation. You don't have any control on whether the accident on the road happens 15 minutes before you are going to pass that place, or one day, or happens later. You don't have that control. So sporadic causes cannot be addressed by SPC. How do you predict? If the process is stable, it is always within plus minus 3 sigma levels, then of course you can safely assume using some basic analysis that it will continue to be so unless there is some external force applied on the process. SPC is widely used in manufacturing, but is also very applicable in services. I just explained the process earlier, the claims process. You can use SPC at the multiple sub-processes also. With this video comes to an end. So we looked at 5 ways in which you can actually implement quality at the grassroots level. So we cover topics like quality control, quality assurance, root cause analysis, flow charting or process mapping, SPC, and the likes. And my endeavor was to explain it in a way that could excite you to learn more about these topics. And this being World Quality Month, I will try and do more of this. So in the three videos till now, you have seen fundamentals on overview of quality. In the second video, you saw more about the frameworks and the tools. And in the third video, you are seeing how does quality work. So hopefully this is being useful. If you like this video, please do share amongst people who might enjoy this kind of topic. And if you are new to the channel, hopefully you will subscribe. I am sure if you have been here earlier, you have already subscribed. With that, till the next video, manage better. See you again.